Hi there and welcome to Tutorial 8 on numerical methods as they arise on the Edexcel Core 3 Maths A-Level module. This particular video is on locating roots and how to do that. As always, we start by looking at the Edexcel specification, and we're in the numerical methods section, as I say, and what we're doing in this video is locating roots of f of x equals 0 using a change of sign where f is continuous. We will do the next section on iteration in another video. Okay, before we start finding roots of a function, we need to first of all consider what a root of a function is. Now, a root of a function, say f of x, is the x value that makes the function 0. So it's what x gives you an output of 0. That is the solution to the equation f of x is equal to 0. What x makes that happen? The x that makes that happen is the root. Now, here's a particular problem for us. Find the roots of the function f of x equals x cubed minus 3x squared plus 3x minus 4. Imagine I just threw that problem at you and you had to find the x values such that that function was 0. Now, you may have some algebra skills that you may be able to employ to do this, but probably the easiest and most intuitive method would be if you could get a graphical piece of software, and there are many online, and you plotted that function, then you could see what value made that function 0, or close to it anyway. You know that 2 makes the function negative, and let's say 3 makes the function positive, and you know somewhere between 2 and 3 it looks like it's about 2.4 something odd. That makes the function 0. So the root, you could at least get a rough approximation of where it is by plotting the graph, and you could zoom in on that graph and actually find the root. So that is one way to find roots. I'd like you to have a go now. You can plot the following by hand, or you could use graphical software. I would like you to determine the two closest whole numbers that the root of f of x lies between. Now, you could use graphing online software. I'll just show you this. If you went online and typed in Desmos into Google, this would be the software you'd be have access to, and say you wanted to plot 4 plus 2x minus 2x cubed, then you could just in here type y equals 4 plus 2x minus 2x to the power of 3, and you could plot that. Okay, so let's go back to this here. You take a second, either go online or plot the following function and tell me the two closest whole numbers that the root of f of x lies between. Okay, I have taken the particular picture from Desmos, and I know that at 2, when x is 2, then I know that f of x is less than 0, and I know that here is 1, when x is 1, I know f of x is bigger than 0. So I know there is a root between the following. It's when x is less than 2 or less than 1. Okay, so in the following, and the two examples we've just seen, if we have a function that's continuous and we know that there is an x value that, say, makes the function negative and one that makes the function positive, there is a root in between those two. Again, we've seen it here. There is an x value that makes the function positive, an x value close by that makes the function negative. We have a continuous function, so that means you can draw it without taking your pen off the page. There must be a root between where x made the function positive and negative. And this is what's called the change of sign rule. And the change of sign rule, which you should note down, says the following. If a function is continuous and changes sign in an interval ab, that means, for example, f of a is less than 0 and f of b is bigger than 0, or the other way around, then there must be a root in that interval. There must be a root between a and b. So, for example, imagine this was my a. I know here that f of a if this function let's call f of x, this function here, f of a, is less than 0 here, and maybe I find another number here, such b, let's say, and this point here is f of b high, then I know, and that is bigger than 0, I know there must be a root between a and b, because the function is continuous, and it was negative when a was put into it, it was positive when b was put into it, which is close by, so at some point between a and b, here in the interval a and b, it must be 0. f of x must take the value 0, and that's as long as it's continuous. So that's a change of sign rule. Let's apply this change of sign rule then. Here's an example. Show that there is a root to the following function between x is 0.5 and 0.6, and this is how you do it. You would work out what f of 0.5 is equal to. So what we're going to do is we're going to work out e to the power of 0.5, so we're going to work out e to the power of 0.5, and then we're going to add 2 times 0.5, and then we're going to subtract 3, and we get minus 0.35, so f of a half is minus 0.35 ... and then we want to work out f of 0.6, so we get our calculator up again, clear it, and we want to work out e to the power of 0.6 plus 2 times 0.6 minus 3, and we get 0.02. So we get 0.02. That's less than 0, that's bigger than 0. And then you can say, as f is continuous, how do we know it's continuous? Well, we know e to the x is a continuous function, 2x is a continuous function, and subtract 3 will keep it continuous. So as f is continuous, then there is a root between x is 0.5 and 0.6, and it's as simple as that. So pause the video now, have a go at the following, and just check your answers against mine in 10 seconds. Right, let's go through this. We want to show that there is a root between -2 and 1, so we want to work out f of -2, and we want to work out f of -1, and hopefully there will be a change of sign. This function is continuous, and therefore there will be a root. Let's just get the calculator. We want to work out -2 cubed, so -2 cubed minus, subtract even, -2 plus 5, and you get -1. So here you get -1, and then let's put in -1 in there. I could just actually do the following, go back to the same function and swap the -2 for -1, hit equals, and we get 5. So this is 5, and then you can say, since f is continuous, there is a root in the interval -2 is less than x, it's less than -1, and you're done. Okay, there's another few for you to do on the next slide. Pause the video, and in 10 seconds I'll show you the answers. Here we go. And the answers to the following 6 are as follows. All you had to do for each of these is put in the values at the end of each of the intervals, show that there's a change of sign, and state that since the function is continuous and there is a change of sign, there is a root. And here were each of my answers. So do tick off you substituted correctly into the functions, and you're stating, very importantly, that there is a change of sign, the function is continuous, and therefore you can deduce there is a root. Right, just I want to think a little bit harder about the change of sign rule. It's we know what it is. It says if a function is continuous and changes signs in a given interval AB, then there is a root in that interval AB. Just want to point out a couple of considerations for you, just for your general background understanding. The first thing is sometimes there can be more than one root. This change of sign rule doesn't say there is one, there is at least one, and there could be more than one. So, for example, if y equals x cubed minus 3x plus 1, if we drew out the graph of that, and say we chose for ourselves, we put in a value of, let's say, we worked out a value of a here, and we worked out that f of a was less than 0, and we took a value of b here, and we saw that f of b is bigger than 0. Since this function is continuous and f of a is less than 0 and f of b is bigger than 0, there's a change of sign. The change of sign rule tells us there is a root. However, we chose a and b quite far apart. In this case, there is one root, two roots, and three roots. So it's just important to bear in mind that this change of sign rule could have more than one root applying to it. It doesn't mean one root necessarily, it can be more than one. Now another thing to say is sometimes you can get a change of sign, you can get no change of root but without a change of sign. Let's see what I mean by that. Imagine we chose our a value again, say here, and this was a, and this was f of a is less than 0. And say we chose our b here, so this was b, so that our f of b was here. That again is less than 0. Now, there are 1, 2 roots between a and b, however we haven't changed sign. So it's just be careful to bear in mind, just because there is not a change of sign does not guarantee there is no root. What you do know is if there is a change of sign, there definitely is a root. If there's no change of sign, you can't for sure say anything. And the last thing to point out is the importance of the continuous comment in our change of sign rule. You can have a change of sign in a discontinuous function. Imagine y equals 1 over x. It looks as such. It's discontinuous when x is 0. You can't draw this without taking your pen off the page. It is not a continuous function. However, although there's a change of sign, there is no root, and there is no root because it is not continuous. So that condition in this sort of theorem that it's continuous is absolutely vital. If the function is not continuous, you can have changes of sign all over the place, but that wouldn't guarantee you a root. Okay, next thing, we need to just talk about finding the intersections of functions. Now, an intersection of two functions is when you have two or more functions, say f of x and g of x, and the intersection is the x value that makes the function 0. That is the solution x of the equation f of x equals g of x. Here's a problem we've got. Find the intersection of f of x is 2x squared and g of x is 1 over x. How would you do that? We're trying to solve 2x squared equals 1 over x. Easiest way, plot the graphs and see where there's a solution. And here I've identified the solution is 0.74 and 1.26. Now, algebraically, it just so happens we can actually do this one. If we were trying to solve this, we would multiply both sides by x, and so we would get 2x cubed equals 1. Then we would halve both sides, or divide by 2, and we would get x cubed equals a half. And then we would divide both sides, we would cube root both sides even, and we would get that x is equal to the cube root of a half. And take our calculator up here, if we were trying to work out the cube root of 0.5, we get 0.793, 0.793, same as on this graphing software here. So we can actually work this one out algebraically. But the easiest way with these sorts of things is to draw the graph and locate the intersection on the graph. Now, Alternatively to doing this, you can just draw the graph of the two functions, but what we are trying to do here is we are trying to solve, as we say, f of x is equal to g of x, okay, which is, we're trying to solve 2x squared is equal to 1 over x. Now just say we subtracted the 1 over x off both sides. This would be equivalent to solving the following. 2x squared minus 1 over x is equal to 0. This here is now a new function. Let's call it something like h of x. Solving f of x is g of x is equivalent to solving this new function equals 0, i.e. locating the root of that function. Now, if we did draw that function, it just so happens that the function h of x looks as so. It looks something like that. And its root is 0.74, the same as when f of x is g of x, because these are essentially the same equations. But what's better about this is we can use the change of sign rule to locate the roots, whereas before we couldn't, because we're trying to find something equal to 0. So what we could have done is we could have said, let's work out h of 0.5 and let's work out h of 1. So and I can use my calculator. I can actually type in this particular function here, 2x squared minus 1 over x, into my calculator as follows. I could just say 2x squared subtract 1 over x, and if I press calculate, it asks me what x I want to put in. I want to put in 0.5 into that, and I get the answer minus 3 over 2. And if I want to put in the answer 1 into that, I press calc again, and I put 1, and I get the answer 1. So I know there's a change of sign between a half and 1, so I know, and I know the function is continuous over this particular portion here, so I know there is a root between a half and 1, and the root was 0.74. So I can translate finding when f of x equals g of x into some other function equals 0, and I can use the change of sign rule to help me locate the roots. So now I just want to show the exact same example, but how it would come up in an exam style question and how I would lay it out. It would say something like, show there is a solution to the equation 2x squared equals 1 over x in the interval 0.7 between 0.7 and 0.8. Okay, first thing I would do is I would state what I am solving. I'm solving 2x squared as 1 over x. I would make 0 on one side. I must make 0 on one side. The easiest thing to do is subtract 1 over x off both sides. So I get 2x squared subtract 1 over x is equal to 0. I would then call my function a new function, maybe h of x is equal to 2x squared minus 1 over x. I would define a function as follows, and I would work out h of 0.7, and I would work out h of 0.8, and I could use my calculator to do these ones. Remember, I've typed in the function there. If I press calc, it asks me what x I want. I want x 0.7, and I get minus 0.45. So I get minus 0.45. And then if I put in x as 0.8, so press calc, 0.8, I get 0.03. So I get 0.03. There's a change of sign. We know this function is continuous here. It wouldn't be continuous at 0, but it's continuous past 0. So continuous, therefore, root for x less than 0.8, bigger than 0.7, and you're done. Right, I've got an example for you to do yourself, and pause the video, have a go. Okay, let's have a go at this. I'm just going to do a tiny little sketch of the graph here, nothing big at all. We know that the graph of the positive root of x looks something like that. And we know the graph of 2 over x looks something like that. something like that. Okay, by sketching the graphs, you have shown that they intersect at one point, so there is one root and one root only. So you've sketched the graphs, and you have shown that, and you can state therefore that there is one root. Show that the solution to the equation lies between this interval. The first thing you do is you would write down what you're trying to solve. In order to show that there's a root, you have to make one side 0. So subtract 2 over x off both sides. You have root x. Subtract 2 over x is equal to 0. And you might call this function something like f of x. You might let that function be defined to be that. Then you want to work out f of 1, and you want to work out f of 2. So you get your calculator, and you define your function. So let's start a new function. Let's define it as the square root of x. Subtract 2 over x as follows, and we press calculate. What x do we want? Well, the first one we want x is 1, and we get -1 as our answer. So we get -1 there, and we do another one, and we put calc, and we put x is 2, and we get 0.41. So we would get 0.41. So change of sign, and continuous. It's not continuous for x is 0, but it's continuous certainly around 1, 2, therefore root. Between x is less than 2 and bigger than 1. And that's all there is to finding roots, or locating the approximate location of roots by the change of sign rule, and also applying this to finding the location of intersections of functions, again using the change of sign rule. And finally, I'll just say, for further work, I would read chapter 4, page 45 to 48, work through the examples, and do exercise 4a, all of it. Then tune in for the next video, which finishes off the section on numerical methods. Thank you for watching the video. I hope you found it useful in your revision.